Okay, so today or now I'm going to show you how to divide complex numbers. But before I do that, I'm going to review how to multiply complex numbers because we actually use multiplication of complex numbers to divide them to make it simpler. Okay, so when we multiply complex numbers, so let's say we've got 2 plus 3i and 3 plus 4i. So we use what a lot of us know as the FOIL method. The first one times the first one, the outside times the outside, the inside times the inside, and the last one times the last one. So it could be kind of complicated thinking, oh, you got to remember FOIL method. It just, this multiplies times both of these back here. So this one has to multiply times this one, gives me 6. This one has to multiply times this one, gives me 8i positive. And then we repeat the process with the second term on the first binomial. So 3i times 3 gives me 9i, and 3i times 4i gives me 12i squared. And this is important. This I squared right here is super important because remember that I squared is equal to -1. So what happens with this -1? This becomes a -1, so 12 times -1 actually becomes minus 12. These always combine on the inside, collecting like terms. I got 8i plus 9i, 17i, and in the front I got a 6, and this was positive. So, and then here again, one more time, collecting like terms, this 6 and this -12 are both real numbers. So 6 minus 12 is -6 plus 17i. And you are done. So that's multiplying complex numbers. Now, there's a special case of complex numbers that we call complex conjugates. So complex conjugates are complex numbers that are identical except for the fact that the middle operation is the opposite. So for example, what do I mean by that? So I'm going to write two complex numbers, and I'm going to purposely I'm going to skip the operation in the middle, right? So they're pretty much exactly the same. What's the difference? One is plus and the other one is the opposite, minus. So these are called complex conjugates. Okay? Now something cool happens when you multiply complex conjugates. This 2 will multiply times that 2, so that gives you 4. And then this 2 times the -3i gives you minus 6i. So I'm done with this one. Now I go with the second term again in the first binomial. So 3i times 2 is positive 6i. So right there as you're going, you can see, you know what? Something interesting is going to happen here, because remember that I said these two are going to combine? Well, these two are going to combine, and what's going to happen when they do combine? They will cancel out. And then if we continue, 3i times -3i will give me -9i squared. And again, I'll keep saying it as long as we're working with complex numbers. This is going to happen a lot. What is I squared? I squared is equal to -1. And it just so happens there that we have an I squared, right? We have an I squared. So this I squared is going to be a -1. So it's going to be 4. This is all gone in the middle. This is going to become -9 times -1. So that is going to become plus 9. Okay, so once you add 4 plus 9, that is equal to 13. So this is the special thing that happens with complex conjugates. The imaginary part will cancel out, and you're going to be left with a real number. Okay, so with that real number, it's going to make our life easier when we're going to dividing the numbers. Okay.